Hi guys, this is the advanced version of the retirement savings calculator. We have done the basic and the intermediate, and this is a scaled up version, that is the advanced version. So let me introduce you to various parameters, the columns and the data in the sheet. This is the year of employment. That is, if you assume that a person starts earning at age 20 and he goes up till age 90, you could just enter 20 here and it'll go on increasing. If you see the formula, which just adds a value and it keeps on increasing. So if I don't want to start from 20 and if I wish to start my earning age from 24, I can just enter 24 here and it'll be adjusted automatically. It'll start from 24 and keep increasing, go to 94. So yeah, this is the year of employment, the age. Now for the rate of interest. Now we have a modifiable rate of interest with a lower value and a higher value. So currently I have placed it between 2 to 6. So the rate of interest will always be between a range, that is 2 to 6. Like it can increase or decrease based on different parameters. So this is just a random value which is being generated, which will be in a specific range of 2 to 6%. So how do we calculate? The formula is you use the rand function, that is the RAND function, which generates a number between 0 and 1. You multiply it by the difference between your higher value, that is 6, and the lower value, which is 2. So basically, your random value generated between 0 to 1 into 4, which is 6 minus 2, plus the lower value 2. So this will give you a random rate of interest here, which will always lie between 2 and 6. So this is just the formula for all the cells in the rate of interest columns, which keeps on changing randomly. So now let's go to opening balance. The opening balance for a year is actually the closing balance of the previous year. So for year 0, because the person has not started earning, the opening balance is 0. And for the next year, for year 1, the opening balance is the closing balance, which is I4. As you can see here, E6 claims to be I5, which is 3124. So that's how it is. Now the invested income. The invested income is the amount one would invest so that he gains a lump sum amount during his retirement. And the retirement income is the amount a fixed amount he would receive during his retirement years. So for now, we have just selected the invested amount as 1500. So based on the value entered here, the invested income would start with 1500. So the formula that has been used for these cells is if the age is less than L5, which is 60. So if the person's age is less than 60, the value to be returned is the invested amount, which is 1500. That is L6. That means if a person has not retired yet, then the amount that he will invest every year will be 1500. But if his age crosses L5, that is if he has retired now, then it means that he would stop investing money for his retirement, that he has already retired, right? So at this point of time, the invested amount will go to 0 and it will return L8. That is this. It'll show you the retirement income. So to review it again, the invested amount, if the person has not retired yet, that is if his age is less than the age of retirement, the amount returned will be invested amount, that is 1500. But if the person has crossed his age of retirement, like in this case, the age is 61. So if the person has crossed his age of retirement, that is if his age is greater than 60, then the value returned will be L8, that is the retirement income, which is 0 in our case. So suppose if I add a value of $200. $200 is the retirement income in our case. And if I reduce the age of retirement to about 30, for example, so at 31 years of age, at 30 years of age, the invested income will be 1500, but at 31, it will no more be called investment income. It will be the retirement income, which is 200 in our case. So accordingly, the values in this table would get changed based on these values. So let us move those back to 60 and let the retirement income be there. So the retirement income will be consistent after the age of retirement, which is 60 in our example. So now that we have invested our income, we need to calculate the interest. So the interest is actually the rate of interest applied over this the total invested income one has. So for year 0, he does not have an opening balance, so the total amount he would invest is 1500. So 5.77 of 1500 is 86.51. So his closing balance for the year is 1586.51. That is, the closing balance is the total of the invested amount plus the interest plus the opening balance. And this closing balance is the new opening balance, which is I4. So that is how the interest is calculated. If the opening balance is less than 0, it will be 0. The interest will be 0. But if the opening balance is not less than 0, then the interest amount will be the opening balance plus the invested amount into multiplied by the rate of interest. This will give you the interest on the amount one has invested in total, and now you have the closing balance. We also have another column that consists of the withdrawal, that is the amount that one can withdraw from his total savings. So for the sake of this sheet, I have assumed that the person would not withdraw any amount from his retirement fund until he retires. So the withdrawal has been kept to 0. So for the withdrawal also, we have like a random increase and decrease. Like one can just enter an approximate withdrawal rate, and then that amount will be automatically deducted from the withdrawal column. So the withdrawal formula doesn't work until one retires. So if his age is less than L5, that is 60, his withdrawal would be 0. But if his age crosses L5, then his withdrawal will be the withdrawal rate, which is 15 in our case, into his opening balance, which is 0. So if you check, after his retirement at age 61, the amount here is 10,413, which is the opening balance into the withdrawal rate, which is 15%. So you can modify these values to get various results and see if you can actually save some money at the last age of 94 or whatever age you choose to see. So this is the current age, the age of retirement, the invested amount that comes here. Then you have the total amount invested in 36 years. This is basically the total number of years you are considering into the table, into the invested amount, that is the total amount invested. The retirement income, as we just discussed, is the amount that one will receive as a lump sum every month after he retires, that is 200 in our case. 4.03 is the average interest rate over a period. That this is just the average of all of these random interest rates. This is the range, lower minimum, the lower and higher value of the rate of interest that we have chosen currently. 1300 is the approximate yearly expenditure. So it is the value entered by a user if he wants to just include a yearly expenditure of a fixed amount to see if he can do a specific amount of spending in a year. Like assume if you want to do $1,300 of spending in a year, and you still want to see if you can do some savings, then you can enter that appropriate value here and see if you would still be able to save some money, or if you would go into losses by withdrawing a higher amount. So that is why we have this value in place. The number of years to run out of savings is 0 currently. It's because there are because the closing balance is never going to 0. So suppose if I reduce his retirement income to 0, and if I increase his withdrawal percentage to about 20%, maybe 10%, I guess it would be 15. Yeah. So when I make this 15%, what happens is the closing balance for the last 8 years goes below 0. So these are negative values here, because of which his close. So basically these values go below the approximate yearly expenditure value, and that is the reason we have this value here. So if the value goes below an approximate yearly expenditure, it is considered that you will not be able to sustain for that financial year. Hence, it will just count the number of years for which your value goes below this minimum, and it will give you a result. And if you have more than 1 year which you will run out of savings, it will give you the message you need to reduce your savings. So suppose if I increase, like I put some retirement income as $500 per month, so you can see that the number of years to run out of savings is 0 in this case, and it will give you a result. You are doing great. Also, we have a graph in place which will basically plot your closing balance for a year versus the age. So the one in blue is the balance, and the one in yellow is the age. So we also have a graph in place here which plots the closing balance versus your spending, and it plots it against the age. So as you can see here, the blue part is the closing balance and the yellow part is the withdrawal that one does over his retirement period. That's it. You're doing great.